Hello everyone, today we will start one topic, electrostatic potential energy of a system of charges. In my last video we discussed the electrostatic potential energy for 2-point charges, and today we will discuss the electrostatic potential energy of a system of charges. Here look at this. In this figure we have taken 3 charges. It may be n number of charges, but here we will deal with 3 charges. Look at this, one charge q1, q2 and q3. Now this q1 is brought from the infinity. Now when q1 is coming, then q2 and q3 is not present. So q1 is coming from infinity, but as there is no other charges, so q1 is not receiving any kind of potential because no other charge is present. So in order to bring this charge q1 from the infinity, the total work done w1 will be 0. But now at the same way, when we are bringing the charge q2, then q1 is present but q3 is not. So w2, if we assume that work done for bringing the charge q2 is w2, then w2 will not be 0. Yes, so what will be the expression for the w2? Because when I am bringing this charge q2, q2 is experiencing potential due to this q1. So as we know that v is equals to w by q, so in order to bring the charge q2, the work done is w2 is equals to v into q2. Now what is the v? This v is due to basically the charge q1. So what is the expression for this q1? It is 1 by 4 pi epsilon naught and q1 by r12. Why r12? Because the distance between q1 and q2 we have taken r12. At the same time, the distance between q2 and q3 we have taken r23, and the distance between q1 and q3 we have taken r13. So that's why r12. So the value of v is 1 by 4 pi epsilon naught q1 by r12 into q2. So the expression comes here like this: q1 q2 by 4 pi epsilon naught r12. So far we have determined the work done to bring the charge q1 is 0, but the work done to bring the charge q2 is this. Now I am bringing the third number of charge q3. So when q3 is coming, then both the charges present q1 and q2. So the work done to bring the charge q3, okay, we are assuming w3. It will be what? V into q3. But this v is what? This v is due to the potential of q1 and q2. So what is the expression for this v? V is 1 by 4 pi epsilon naught q1 by r13. Why? Because at q3 the potential due to q1 is 1 by 4 pi epsilon naught q1 by r13. Why? Because the distance is r13 plus 1 by 4 pi epsilon naught q2 by r23. Why r23? Because the distance between q2 and q3 is r23. So this is the total potential is already present when I am bringing the charge q3. So w3 is equals to vq3. We have to put this value here. So the w3 is equals to how much? 1 by 4 pi epsilon naught q1 by r13 plus, if I take common directly, q2 by r23 into q3. So after simplification the result will be like that: 1 by 4 pi epsilon naught, then q1 and this q3 will be multiplied, q3 by r13 plus q2 q3 by r23. So we have already found w3, w2 and w1. So what is the total work done? wt, t for total, is equals to w1 plus w2 plus w3. Now I am putting all this value. W1 is what? 0. W2 is what? W2 is already found, 1 by 4 pi epsilon naught Q1 Q2 by R1 2 plus W3 is how much? 1 by 4 pi epsilon naught Q1 Q3 by R1 3 plus Q2 Q3 by R2 3. So the total expression for Wt and this work done will be stored as potential energy of the system is equals to U is equals to how much? Is equals to, after taking common 1 by 4 pi epsilon naught, we will get these expressions like this: Q1 Q2 by R1 2 plus Q1 Q3 by R1 3 plus Q2 Q3 by R2 3. So this is the expression for potential energy for this system of charges. Now if there is n number of charges, how can we write all these things in the form of summation? It is 1 by 4 pi epsilon naught, and this is if we consider n number points or all points, then Qj Qk by Rjk. So J value will be what? 1 1 2 2 like that, and K is what? 2 3 3 4 like this, and Jk. So this is the expression for this electrostatic potential energy of a system of charges. Thank you. Bye bye.